Chapter 7, Functional Group, Class Life Sciences. Part 2, Quantitative Elemental Analysis. At the end of this session, students should be able to determine the mass and percentage by mass of elements in an organic compound, determine the molecular formula and the empirical formula of an organic compound. Part 3 of Chapter 7, Quantitative Elemental Analysis. Quantitative elemental analysis shows the amount, mass, and percentage by mass of chemical elements that constitute an organic compound. To determine the mass and percentage by mass of its chemical elements, we burn a sample of the organic compound. During this burning, carbon are transformed into carbon dioxide, hydrogen atoms are transformed into water vapor, and nitrogen atoms, if they are found, are transformed into nitrogen gas N2. For example, if we have an organic compound substance S formed of carbon, hydrogen, oxygen, and nitrogen of general formula CX, HY, or Z, and T, where X is the number of carbon atoms, Y number of hydrogen atoms, Z number of oxygen atom, T number of nitrogen atom in this organic compound. We burn a mass M. By complete combustion, we obtain CO2 of mass M, and we obtain water vapor of mass M, and we obtain nitrogen gas of volume V. Based on this result, we will show how to determine the molecular formula of this compound. 3.1 Mass and percentage by mass. How can we determine the mass and percentage by mass for each element? First, of carbon atom. Carbon atom, when burned by the complete combustion of carbon with oxygen gas, produce CO2. Then carbon atoms in the organic compounds are transformed into CO2. According to stoichiometry of this reaction, 1 for carbon atom and 1 for CO2, number of carbon over 1 equal number of mole of CO2 over 1. Then N number of mole of carbon equal number of mole of CO2. And we know that number of mole equal mass over molar mass. Then we can replace number of mole by mass over molar mass for each one. Then mass of carbon over molar mass of carbon equal mass of CO2 over molar mass of CO2. Mass of CO2 is given, molar mass of carbon and CO2 are given, or we can calculate the molar mass of CO2. Molar mass of C is given. Then we can deduce the mass of carbon equal mass of CO2 times molar mass of carbon over molar mass of CO2. And then we can deduce the percentage by mass of carbon, which equal mass of carbon over mass of the substance S times 100. Now for hydrogen. Hydrogen atom by complete combustion give H2O. 2 hydrogen atom of the organic compound S with half oxygen molecule, that means 1 oxygen atom, give H2O. According to stoichiometry of this reaction, 2 hydrogen atom give 1 molecule H2O, that means 2 mole of hydrogen give 1 mole of H2O. The number of mole of hydrogen over 2 equal number of mole of H2O over 1. We replace number of mole by mass over molar mass. The relation becomes mass of hydrogen over 2 molar mass of hydrogen equal mass of H2O over molar mass of H2O. Also, mass of H2O is given, and molar mass of hydrogen equal to 1, molar mass of H2O equal 18. Then we can deduce the mass of hydrogen according to the relation. Mass of hydrogen equal 2 molar mass hydrogen times mass of H2O over molar mass of H2O. And after that, we can deduce the percentage by mass of hydrogen, which equal mass of hydrogen over mass of the organic substance where hydrogen is found times 100. Now for nitrogen. Nitrogen, we obtain nitrogen gas, the volume, based on the volume of N2 given, we can deduce the number of mole of nitrogen gas formed by the following relation. Number of mole of N2 equal volume of N2 over Vm, molar volume of gas. Then we can calculate the mass of nitrogen gas formed by the relation mass of nitrogen gas equal number of mole times molar mass of nitrogen gas. And we know that according to the law of conservation of mass, the mass of nitrogen gas formed is equal to the mass of nitrogen atom in the organic substance, because the nitrogen gas released from the nitrogen atoms found in the organic compound S. Then mass of nitrogen in the organic compound S equal mass of nitrogen gas formed, which is calculated. After that, we can deduce the percentage by mass of nitrogen equal mass of nitrogen over mass of the organic substance times 100. For oxygen, the mass of oxygen equal sum of the mass of elements calculated, carbon, hydrogen, nitrogen, and other elements. We subtract the sum of the mass of this element from the mass of the organic substance. Then mass of oxygen equal total mass of the element, which is the mass of the organic substance, minus mass of other elements, carbon, hydrogen, nitrogen, and other elements if we have. The same percentage by mass of oxygen equal sum of percentage, which is 100, minus sum of the percentage of other elements, percent carbon, percent hydrogen, percent nitrogen, and so on. Now, after we have learned how to calculate the mass and percentage by mass of each element, now how can we determine the molecular formula of the organic compound? We have two methods. First method, from the mass of each element. We have that carbon, the organic substance C, X, H, Y, or Z, and T is formed of carbon, hydrogen, oxygen, and nitrogen. Then X carbon atom and Y hydrogen atoms and Z oxygen atom and T nitrogen atom give the organic compound. Then by stoichiometry, number of carbon over X equal number of mole of hydrogen over Y equal number of oxygen over Z equal number of nitrogen over T equal number of mole of the organic substance over stoichiometry, which is 1. We replace number of mole by mass over molar mass. Then mass of carbon over X times molar mass of carbon equal mass hydrogen over Y times molar mass hydrogen equal mass oxygen over Z molar mass oxygen equal mass nitrogen over T molar mass nitrogen equal number of mole of S equal mass S over molar mass S. Then the relation becomes law of proportion. Mass of carbon over 12X equal mass of hydrogen over Y equal mass of oxygen over 16Z equal mass of nitrogen over 14T equal mass of S over molar mass of S. We have replaced the molar mass for each element by its value. Carbon 12, hydrogen 1, oxygen 16, nitrogen 14, and molar mass of S should be given to determine the X, Y, Z, and T. First, we take the first, to determine X, we take the first ratio with the last ratio. We have only one unknown, which is X. We can deduce S. Then we take second with the last, third with last, fourth with last to determine Y, Z, and T. And when we solve an application, we will see how to apply these relations. This is the relation to be memorized. Second case, from the percentage by mass of each element. We start from the last relation, mass of carbon over 12X equal mass of hydrogen over Y equal mass of oxygen over 16Z equal mass of nitrogen over 14T equal mass of S over molar mass of S. If we multiply this proportion by 100 over mass of S, the relation remains the same. The fraction remain equals. Then mass of carbon times 100 over 12x times mass of S equal mass hydrogen times 100 over Y times mass of S equal mass oxygen times 100 over 16Z times mass S equal mass nitrogen times 100 over 14T times mass S equal mass S times 100 over molar mass S times mass S. We know that mass of carbon times 100 over mass of S equal percent by mass of carbon, and mass of hydrogen times 100 over mass of S equal percent by mass of hydrogen. The same mass of oxygen times 100 over mass of S equal percent oxygen. Mass nitrogen times 100 over mass of S equal percent nitrogen. We subtract by simplify mass of S and mass of S. The relation becomes percent carbon over 12x equal percent hydrogen over Y equal percent oxygen over 16Z equal percent nitrogen over 14T equal 100 over molar mass S. This is the law of proportion based on percentage by mass of each element. This relation can be applied directly to determine X, Y, Z, and T if we are given the molar mass of S and percentage by mass for each element. Application 1. The complete combustion of 225 mg of an organic compound S produces 220 mg of carbon dioxide, 135 mg of water, and 61 ml of nitrogen gas in conditions where the molar volume of gas is Vm equal 24.35 liter per mole. 1. Determine the percentage by mass of each element of the compound S. 2. Deduce the molecular formula of S knowing that its molar mass is 45 grams per mole. Solution of application 1. We have an organic compound S of mass M equal 225 milligram. The complete combustion of this mass of S produces CO2 of mass M equal and water vapor of mass equal 135 milligram and nitrogen gas N2 of volume equal 61 milliliter in condition where the molar volume Vm equal 24.35 liter per mole. 1. We should determine the mass and percentage by mass for each element. First, for carbon, we start carbon plus O2, produce CO2, then number of mole of carbon over 1 equal number of mole of CO2 over 1, then mass of carbon over molar mass of carbon equal mass CO2 over molar mass CO2, then mass of carbon equal molar mass carbon times mass CO2 over molar mass CO2 equal molar mass carbon 12, mass CO2 220 milligram over molar mass of CO2 44 equal 60 milligram. Now percent by mass of carbon equal mass of carbon over mass of S times 100 equal mass of carbon 60 over mass of S 225 times 100 equal 26.66%. Now for hydrogen atom when burned in presence of O2 produces H2O. We balance 2 hydrogen multiply H by 2, 1 oxygen multiply O2 by half. Then number of mole of hydrogen over 2 equal number of mole of H2O over 1. Then number of mole of hydrogen equal mass of hydrogen over molar mass of hydrogen times 2 equal mass H2O over molar mass H2O. Then mass of hydrogen equal 2 molar mass hydrogen times mass H2O over molar mass H2O equal 2 times molar mass hydrogen 1 mass H2O equal 135 over 18 equal 15 milligram. Now percentage by mass of hydrogen equal mass of hydrogen over mass of S times 100 equal 15 over 225 times 100 equal 6.66%. Now for nitrogen, first we calculate number of mole of N2 from the volume V N2 over Vm equal 61. Here the volume should be in liter. We multiply from milliliter to liter by 10 negative 3 over Vm 24.35 equal 2.5 10 negative 3 mole. Now we calculate mass of N2 equal number of mole of N2 times molar mass N2 equal 2.5 10 negative 3 times 28 and 14 and 228 equal 70 10 negative 3 gram equals 70 milligram. According to the law of conservation of mass of nitrogen in the organic compound S equal mass of N2, which is equal to 70 milligram. Now we can deduce the percentage by mass of nitrogen equal mass nitrogen over mass of S times 100 equal 70 over 225 times 100 equal 31.11%. Now for oxygen, percent by mass of oxygen 100 minus percent carbon plus percent nitrogen, hydrogen plus percent nitrogen equal 100 minus 26.66 plus 6.66 plus 31.11 equal 35.57%. This is part 1, the percent by mass for each element. Part 2, we should determine the molecular formula of S, knowing that its molar mass is 45 gram per mole. We apply the a law of proportion by mass. Percent carbon over 12x equal percent hydrogen over y equal percent oxygen over 16Z equal percent nitrogen over 14T equal 100 over molar mass of S. Then percent carbon 26.66 over 12x equal percent hydrogen 6.66 over y equal percent oxygen 35.57 over 16Z equal percent nitrogen 31.11 over 14T equal 100 over molar mass 45. We take first ratio with the last ratio, then we can deduce x equal 26.66 times 45 over 12 times 100 equal 1. Y 6.66 times 45 over 100, almost approximately 3. Z equal 35.57 times 45 over 16 times 100, almost 1. T equal 31.11 times 45 over 14 times 100, approximately 1. Then the molecular formula of S, C1H3ON. Now, CT empirical formula, determination of the empirical formula. But first, what is the empirical formula? The empirical formula of a chemical compound is the simplest positive integer ratio of atoms present in a compound. For example, CH2O is the empirical formula of methanol HCHO, of molecular formula CH2O, and of ethanoic acid of CH3COOH, molecular formula C2H4O2, of lactic acid CH3COOH, of molecular formula 1, 2, 3, C3H3 4, 5, 6, O3, and of glucose C6H12O6. In the second compound, if we take 2 as common factor, this molecular formula becomes CH2O 2 times. The third is, we take 3 as common factor, then the molecular formula is CH2O 3 times. And for glucose, if we take 6 a common factor, CH2O 6 times. These compounds have the same empirical formula CH2O, which is the simplest positive integer ratio of atoms present in this compound. Now, to explain how to determine the empirical formula of an organic compound, we will solve this example. The analysis of an organic compound S gives the following mass composition: carbon 54.54%, hydrogen 9.09%, oxygen 36.36%. To determine its empirical formula, we apply the law of proportion of mass, proportion by mass. Percent carbon over 12x equal percent hydrogen over y equal percent oxygen over 16 Z. Here we have no molar mass, then we stop the relation here. We replace each percent by its value. Percent carbon 54.54, percent hydrogen 9.09, percent oxygen 36.36. Second or third step, we simplify each fraction. We divide 54.54 over 12, then it becomes 4.545 over x. Divide 9.09 over 1y, remains 9.09. We divide 36.36 over 16, we obtain 2.2725 over z. Now, z is the unknown that has the smallest numerator. This is the smallest numerator among these three numerators. Then z is the unknown that have the smallest numerator. Then we calculate x and y in terms of z. That means we will take z as a common factor and we replace it by z when it takes by 1 when it takes as common factor. Then suppose that z equal 1, then the relation becomes x equal 4.545 times 1 over 2.2725 equal 2, and y equal 9.09 times 1 over 2.2725 equal 4. Therefore, the molecular formula of S is C2H4O times Z, or Z times, because we took Z as a common factor. The real molecular formula is C2Z H4ZOZ. We take Z as common factor. The C2H4O is the empirical formula of this compound S. To determine the molecular formula, we should determine Z. We should have the molar mass of the compound. Then we can deduce Z and we replace it by this value and we deduce the molecular formula. Then this is how to determine the empirical formula of an organic compound. And this is the end of part 2 of chapter 7, functional group.